Hi again everyone, Chris Tisdell here again. In this presentation I'm going to continue my series of videos that give a basic and gentle introduction to complex numbers. So in the previous videos I've been showing you some basic operations with complex numbers such as addition, subtraction, scalar multiplication and multiplication of two complex numbers. And I've talked a little bit about the geometry. In this presentation, I'm going to show you how to divide by a complex number. And it centers around the idea of a conjugate. So let me share my screen with you and we can get underway. Okay, so in particular, we're going to use an idea that involves the conjugate of the denominator. So we're going to multiply through by a factor of 1 that turns the denominator into a real number. And the point of doing this is that you then have a form, you have a Cartesian form, which you can plot on an Argand diagram or in the complex plane, and you can do stuff with it. So let me give you an example. And this is a quick one, and I'll do one by hand in a minute. Suppose I have two complex numbers, z and w. Z is 2 plus I, w is 3 plus 2i. Then let's have a look at the division of z by w. Okay, so I've got 2 plus I all over 3 plus 2i. What we would like to do is get that into a form, say x plus yi for some numbers x and y, into the Cartesian form. Okay, well, what do? Well, we look at the denominator and we look at the coefficient of the I. And whatever the coefficient of the I is, we just change the sign on it. And we multiply through by a factor of 1. So you can see here, I've looked at the coefficient, I've changed the sign there, and I've multiplied by this on this, which is just a factor of 1. So I'm not changing it at all. Okay. So 3 minus 2i is called the conjugate of 3 plus 2i. And if there was a minus sign down here, you'd have plus signs here. Okay, now, in the previous video, I showed you how to multiply complex numbers together. Okay, you just distribute in the normal fashion. Remember that I squared equals -1. Okay, so let's work with the numerator first. If I expand the brackets, I'm going to get 2 times 6, and if I multiply the i's together, I'll get -2i times I. So that'll give me -2i squared. I group those together because I know they're going to give me a real number. Then you just multiply the i's with the real numbers. So 2 times -2i, -4i, 3 times I, 3i. So group those together and you'll add or subtract those together. Now I squared equals -1, so this will be -2 times -1. So it'll be 8 up here and -i up here. What about the bottom? Well, the bottom is similar. Okay, you can expand it in the normal way if you want to, but the secret in this form is that this bottom bit is just going to become a real number. All the i's are going to disappear. Okay, so just to prove that to you, you've got 3 times 3 plus 2 times -2i. That'll be -4i squared. Group them together. And then the other one, you've got 3 times -2i, -6i, plus 3 times 2i. So they will cancel off, and you'll be left with 9 plus 4 down here, because I squared equals -1. Okay, so 9 plus 4 gives you 13, and if you want to split that up and write it in this Cartesian form, I can do it like this. Okay, so the important thing in that method or that example is that the denominator is now real. That means we can easily plot the quotient here in, say, the complex plane or in an Argand diagram. Now, I talked about the geometric interpretation of multiplication of two complex numbers. Well, what about division? Well, I'm not going to talk about it too much, but you can, if you interpret division as a sort of inverse to multiplication, then the interpretation of division can also be seen through a rotation or a stretching principle. Let's do an example by hand. Here I've got one complex number divided by another one, and we're asked to simplify it into the Cartesian form x plus yi. So what I'm going to do is, let's call this, say, w, okay? I'm going to multiply through by a factor of 1, where I look at the denominator and I choose the conjugate of this. Okay, so I look at the coefficient of I, it's a -1. So let's change the sign on that, change it to a +1, and then multiply through by a factor of 1. So instead of 3 minus I, I have 3 plus I now. Okay, well, let's expand this as we normally would in the usual distributive fashion. Okay, so in the numerator, the real part's going to be 2 times 3, which is 6, minus 7i times I. That'll be -7i squared. Okay, what about the i's? Well, I've got 2 times I, which will be 2i, minus 7 times 3, which will be -21i. Okay, so what about the bottom now? Well, same thing, 3 times 3, which is 9, minus I squared. What about all the i's? Well, I've got 3 times I and -3 times I. So they're going to cancel out, aren't they? Okay, so here I've got, remember, I squared equals -1. So here I'm going to get 6 plus 7. So 6 and 7 is going to be 13. Over here I've got -19i up there. And down the bottom I'm going to have 9 minus -1, which is going to be 10. Okay, so if I just simplify that, I'll get the following. Okay, so that is my answer. Okay, you can see now it's in this Cartesian form, and if I wanted to, I can plot it on an Argand diagram or in the complex plane. Okay, so that's my presentation on division. In the examples I looked at, you were always dividing a complex number by a complex number. You could divide a real number by a complex number, and the ideas would be the same. You always use the conjugate and a factor of 1. So I hope you enjoyed this presentation. Please post some comments if you have any suggestions or feedback. I'd love to hear them. And please join me for the next video in this series on complex numbers. Thanks for watching. Bye.